Hi, my name is Amber. I'm a senior at Pomona College, and this is a project that I worked on in the fall, last fall, called The Implications of Missing Traffic Stop Data. So let's start with the motivation. Racial profiling is bad, as we know, and has led to the collection of a lot of traffic stop data. As this data has been made available to the public, researchers have tried to model the data to look for evidence of discrimination. The only problem is that the models that they use do not handle missing values. So most and the data sets that like these traffic stop data sets have a lot of missing values. As a result, these studies use complete case analysis, which means that they simply remove all observations with even one missing value. These two scholars, Cheney and Welsh, they draw attention to this problem, saying that these missing values probably don't occur randomly. Police officers are the ones recording the data. They're also the ones who are going to be punished if the data has evidence of discrimination. So chances are they're not going to accurately and comprehensively always be wanting to record their traffic stops. And that's getting at the fundamental basis of my project. What are the trends of missing values in traffic stop data? So let's just jump into some definitions. I'll let X be my data set where lowercase xij is the entry in the ith row and the jth column. And my data set, I'll just say it has n observations and k variables or k columns. I have this missingness indicator function that will return 1 if the entry is missing and 0 if it's observed. Then I'll add up with this missingness indicator function, I can count the number of missing values in a row and then divide that by the number of columns, and that will give me the percentage of missing values in a single row. Then I can extend this to the entire data set by adding up the row-wise missingness across all rows and dividing by n. And this will just give me the percentage of missing values in a data set. Here is a toy example that is 4 by 4, so the denominator is 16. And then there's 2 missing values, so the dataset SMR is 2 over 16. This is nice, but the dataset SMR gives you only one number to get a sense of the missing values of a dataset. What if I want to get what if I want to understand the missingness within a dataset? Then I'll need to actually restrict a variable from my missingness calculation, which I'll do next. So the row-wise restricted SMR will not include a variable, say a variable j prime, in my calculation. So when I count up the number of missing values in the row, I won't include column j prime. And then when I divide by k, I'll actually divide by k minus 1 because I'm not including j prime. This is shown in this example. So when I restrict by race, the denominator is now 3 as opposed to 4. So in the first row, the race restricted row-wise SMR would be 1 over 3. And for the second row, it would be 0. Now I can extend this to the whole data set again, kind of like I did before, except I'm going to do it by the variable that I'm restricting by. So it's kind of confusing, but we'll just work through an example. So say I want to get the SMR by race. So let R be my column index corresponding to the race variable. And just for simplicity, let's assume that in this data set, race only takes on 3 values, white, other, and NA. Then we can filter the data set based on the values of this race variable. So basically, we'll have these index sets, W, parentheses W, parentheses O, parentheses NA. For all I in the set parentheses W, the race variable will be white. So basically able to filter the data set for white drivers, other race drivers, and NA race drivers. With that, we can see how the missingness is for different race drivers in the data set. So that's kind of shown here. The notation is a little bit kind of thorny. I try to make it as simple as I could, but essentially all you're doing is adding up the race restricted row-wise SMR for white drivers, and then you're going to divide by the number of white drivers in total. So that will basically give you the average missingness for white drivers and so on. In this example, right, we have 2 drivers identified as Black, and then we're restricting by race. So our denominator will be 2 times 3, not 2 times 4. And then there's 1 instance of missingness. So then the Black SMR will be 1 over 6, the Hispanic SMR would be 1 over 3, and then the other race SMR would be 0 because there's no missing values. So we can apply this like SMR by a variable to other continuous variables in the data set. We just need to be a little bit more careful about how we partition indices because we want the index sets to be large enough because we're taking averages. We want it to be large enough to have a meaningful SMR. So for date, rather than partition by the actual day, we're going to partition by week just so that we have a large enough set. And then for time, we're not going to partition by like the hour of the day. We'll partition by day versus night of the month. And that will, again, give us a large enough index set. So with these definitions out of the way, we can now introduce the data that we'll be visualizing. So the Stanford Open Policing Project has several dozen data sets encompassing about 2 decades, and they are about 100 million observations. They all come from different data sets, meaning like one will come from like Oakland, one will come from San Francisco, and each data set records a different set of variables. And that can be a little bit difficult. So this box plot gives a sense of what that might look like. So each dot in the box plot represents one column in a data set, and then the x-axis is the number of times that column shows up. So you can see that contraband alcohol, for example, is a very rarely recorded variable, and honestly, it's not too important when it comes to modeling like racial profiling, right? While like citation issued or arrest made, you're going to find those on the right side of this box plot because they're recorded quite frequently. So because we're looking at the SMR of a data set, it's a rate, right? So the denominator matters, the number of variables matters, or K matters. And so we're going to only look at variables that are frequently recorded that are important for racial profiling studies. Like the missingness of these frequently recorded variables are more important than say like contraband alcohol or like vehicle color. So more explicitly in our analysis, we'll only look at 9 variables that are in the categories of driver demographic, situational details, and outcomes. And then just another note, I only use a 30% random sample of each data set just for computational reasons. So with all of that setup done, we can finally talk about the visualization. So we'll begin with the race SMR. So this is a box plot that for which each dot is the race SMR for one data set. And on the y-axis, you'll see the number of observations that are shown in the box plot. If you compare the white, Black, Hispanic, and Asian Pacific Islander box plots, you're going to see that the SMRs are about the same, right? We're not seeing a huge shift in distributions. We're not seeing that like, oh, a minority race driver is going to have like a very poorly recorded traffic stop. So that's like kind of good news. What we do see is that if your race is not recorded, other information is probably not recorded either in your traffic stop. We're seeing a much higher median. We can show this same box plot with a scatter plot instead, where we have the minority race SMR on the y-axis and then the white race SMR on the x-axis. And this kind of gets to the same idea, where the minority and white SMRs are quite similar, unless it's an NA race driver. And we'll see what we can do about, or like I'll talk a little bit about NA race drivers in a bit, but essentially, there's very little information if your race is already missing about what's going on with you. And that's important because there's a lot of NA race drivers in the data set. What did those drivers have to inform our statistical models? But we don't know because they're excluded from the data set. The story is a little bit more interesting when we look at SMR by date. So here are 6 data sets for which each dot represents the weekly SMR of that data set. I chose these 6 examples because they get at a few of the main categories of how SMR changes by date, which is kind of cool, right? So here we have level changes in Iowa and Nashville. We have these interesting shapes like functional relationships in Wichita and South Carolina. And then in St. Paul, you see an increase in the variability of your missingness after a certain point in time. So these scatter plots show that missingness does vary by the date. And when you exclude missing values from your studies, from your statistical models, then you're going to be artificially weighting traffic stops from a certain time period, which is like, do you really want to be doing that? I don't know. So I just want to draw your attention to Louisville, Kentucky, where we see that it looks quite benign, right? Quite innocuous. Like there doesn't seem to be much trends. But when we disaggregate by time or day and night, we're going to see that the day and night traffic stops are actually recorded differently. But then they're just kind of combined in the previous plot, so it doesn't look like much, right? So the night traffic stops have like much more missingness than the daytime traffic stops. And you can see how the day versus night recording is different for like 3 other data sets too. So again, I only show these few examples to get at the main ways in which missingness can be affected by date and time. So these are all the visualizations that I have for you today. Just to summarize my results, we're seeing that by race, there isn't much evidence that certain drivers are being recorded much less or much more. However, we're seeing that there is a relationship between date and time with how a traffic stop is recorded. Future research could look at missingness mechanisms behind the traffic stop data. So there's like a lot of work on like missing at random, missing completely at random, missing not at random. And then based on that, there's different imputation methods so you can fill in those values, which kind of gets at the original this kind of gets at the question I raised about NA race drivers. Who are these NA race drivers? How might they inform statistical models of racial profiling, racially biased policing. So yeah, that's all that I have for you today. I'd be happy to take any questions. Yeah, thank you for listening.